Hello everyone, welcome to Brain Blitz Audios. Today we're starting off a new series, UPSET/UPSEE, questions with solutions. So today we're going to be looking at some questions of previous years which were asked in UPCET, which was also known as UPSEE of the year 2018. So both of these names are referring to the same exam. This is the exam conducted by the Abdul Kalam Technical University for admissions into premier universities in the heart of India. So therefore, these exams are quite important, and since there are a lack of preparation materials, we thought it would be best if people have access to questions as well as their solutions. So we're gonna look at some questions which were asked in the 2018 edition of UPCET, which was then known as UPSEE. So here comes our first question. A very long solenoid is made out of a wire with n turns per unit length. The radius of the wire is A and it's negligible compared to its length L. The interior of the cylinder is filled with materials such that the linear magnetic permeability varies with the distance r from the axis according to the below equation. So mu1 is constant for 0 less than r less than some constant b, and mu2 is constant for b less than r less than the maximum radius, which is a. We need to find out the self-inductance of the solenoid. Now, self-inductance for a normal solenoid, L, will be equal to mu times r times n square times pi a square. So n stands for the number of turns per unit length, r is for the length, a stands for the radius, and mu is the linear magnetic permeability. Now, in this particular scenario, the linear magnetic permeability mu varies with the radius. So therefore, the value of L will be mu1 times the length L times n squared times pi times b squared, because mu1 is constant for the radius extending from r is equal to 0 to r is equal to b. So the total radius will be b. And for the constant mu2, the length will be L. Again, the number of turns is n squared. Pi remains the same because it's a constant. However, the radius will now be b. It will be a, which is the total radius, minus b. So a squared minus b squared. So it'll be basically pi a squared minus pi b squared. So we just took the pi out, so we get a squared minus b squared. Now, here, the length of the solenoid, the number of turns per unit length, and pi are all same. So pi n squared L times, inside the bracket, you will get mu1 times b squared, and it'll be added to mu2 times a squared minus b squared. So therefore, the correct answer will be option C. So what we're basically doing is we're taking out the entire cylinder, and since the coil is filled up with two separate materials, mu1 and mu2, the total self-inductance will be dependent on the self-inductances of both these materials simultaneously. And when we're solving that, you'll get option C, pi n squared L times mu1 b squared plus mu2 times a squared minus b squared. Let's look at another question of physics. A stream of non-viscous liquid emerges from a very short outlet tube at the base of a large open tank, in which the depth of the liquid is h. The tube is at a fixed angle theta to the ground as shown right here. So therefore, the maximum height of the stream, that is y, is it'll be h sine square theta, h sine 2 theta, 1 by 2 h sine 2 theta, h tan square theta. So, how do we solve this question? Well, here we're going to use we're going to use a result of the Bernoulli's theorem, which is called as the Torricelli's law. Now, the Torricelli's law states that the velocity of water exiting a hole of a tank will always be equal to under root of 2gh, where h refers to the vertical distance between the surface of the water and the hole. So, according to Torricelli's law, the deeper you puncture a hole into the tank, the higher force that the water ejects when it moves out. So, therefore, u will be equal to under root of 2gh. Now, this is true when the hole is punctured such that the water goes out straight. If the hole is tilted at an angle theta, the velocity will now have a vertical component and a horizontal component. And so the vertical component for our particular question, so the vertical component of the velocity of water leaving the tank will be v equals under root of 2gh, that is u, times sine theta. Now, this is because we're dealing with the vertical component, so sine theta, so if you have theta, then cos theta is along the base and sine theta is perpendicular to the base. So we get v is equal to under root of 2gh times sine theta. Now, the water from the hole is being ejected at an angle theta, so it undergoes projectile motion. So the maximum height, that is h max, will be equal to u squared by 2g. It's basically u squared sine square theta divided by 2g. But then, since the vertical component is taken as v, so therefore h max will be v squared divided by 2g. So v squared is basically u squared sine square theta. Here u is under root of 2gh, so under root of 2gh squared will be 2gh times sine square theta divided by 2g. So both the 2g's get cancelled, so therefore the maximum height up to which the water moves is h times sine squared theta, where h refers to the total height of water in that cylinder before puncturing the hole. So therefore, the correct answer among the four options is option A, h sine squared theta. So we're using two things here. One is we're using Bernoulli's theorem, especially Torricelli's law, and the next part of physics that we're using is projectile motion. So we find out the maximum height of the projectile of water that's being shot out of the hole, which is inclined at an angle theta. Let's now look at some questions of chemistry. If a mixture of FeO and Fe3O4 contains 75% of iron, what will be the percentage amount of each oxide in the mixture? So here we are having a mixture containing FeO and Fe3O4. Now note that Fe3O4 is by itself a mixture. It contains FeO and Fe2O3 molecules. So therefore, in this particular mixture, we have two molecules of FeO for every single molecule of Fe2O3. So that is the current ratio that we have. And in these molecules, we have, in these mixtures, for each individual component, iron is present in a specific ratio. So we can find out that ratio now. For FeO, the percentage of iron will be equal to, given it'll be the molar mass of iron, that is 56, divided by the molar mass of FeO, which is 56 plus 16, that gives you 72, times 100, since we're talking about percentages. So 56 and 72 are both divided by 2. You get 28 and 36. Once again, you can divide them by 4. So 7 times 4 gives you 28. 9 times 4 gives you 36. So it's basically 700 divided by 9. And 9 times 7 is 63. Remainder 7. 0 goes in. It's again 7 once again goes into the quotient, and we're going to be continually dividing. We're going to continually get 70, and we have to divide that by 9 in order to get 7. So the percentage of iron is 77.78%. So that's the amount of iron present in the portion of FeO that's present in the mixture. Now, in the portion of Fe2O3, the percentage of iron will be 2 times the mass of iron. So since we have 2 iron molecules here, iron atoms here, so therefore 2 times 56 divided by the total mass of Fe2O3. So 2 times 56 is 112, plus 3 times 16, so that's 48. So you get 160 as the denominator, the total mass. And you have to multiply this by 100 to get the percentage. So 2 times 56 is 112, divided by 160 into 100. So we can cancel out one of the zeros. Both 112 and 16 are, both of them are divisible by 2. So 16 times 2 gives you 8. 112 times 2 gives you 56. And then 56 and 8 can be divided. So 7 times 8 gives you 56. So therefore 7 times 10, that is 70%, is the total percentage of iron present in the portion of Fe2O3 in the mixture. So now we know that iron is present 70% in Fe2O3 and 77.78% in FeO. So now what do? We are now going to assume that X grams of FeO and Y grams of Fe2O3 are mixed in this particular mixture to obtain a mixture that has 75% of iron. So for a mixture to have 75% of iron, the total percentage of iron will be 77.78% of iron times X grams plus 70% of iron times Y grams gives 75% of the whole mixture, which will be X plus Y. So what we're going to do, it is pretty simple. We're going to distribute 75% among X and Y. So what we get is 77.78% minus 75%. This is with respect to X, and on the right hand side it's 75% minus 70%. This is multiplied with Y, that is the mass of Fe2O3. So what we get is 2.78% of X will have the same mass as 5% of Y. So X divided by Y will give you 5% divided by 2.78%. percentages get cancelled out, and we will get 500 divided by 278, which both of them can be divided by 2 to get 250 divided by, let's divide 278 by 2, so that's 13, 26, 1, 18, and then 9. So 250 divided by 139 is the ratio between x and y. So now that we know the ratio of the masses of x and y, we are now going to use that to find out the percentage. So the percentage of FeO in x grams will now be equal to the mass equivalent, that is 250, divided by the total, that's 250 plus 139, which is equal to 389. So it's just a matter of addition. 9, 5 plus 3 is 8, 2 plus 1 is 3. And then into 100. So basically we now have 25,000 divided by 389. So let's start solving it. So let's, since we have 3 here, 3 times 6 is 18, so let's start off by using that. So 389 times 6, 9 times 6 is 54, 8 6 are 48, plus 5 is 53, 3 6 are 18, plus 5 is 23. So 2334 is 389 times 6, and we can't add another 389 because it will be over to 2500. So this is the closest value. So 6, put the 6 in the quotient, and you get 2334, and then 10 minus 4 is 6, 9 minus 3 is 6, 4 minus 3 is 1, and then 0. So 1660. When we take 389 times 4, 3 4s are 12, so 9 4s are 36, 8 4s are 32, 32 plus 3 is 35, 3 4s are 12, 12 plus 3 is 15, so that's the closest value to 1660, so 4. 1556. Now you can continue solving it, but right now we know that among the following options, 64.1% of FeO is present in one of the options. So we know that we have got part of the right answer. So 64.1% of FeO is present in the total mixture. So therefore, the correct option will be option A, 64.1% of FeO. And if you want to find the percentage of Fe2O3, that's easy. It's 100 minus 64.1, so that's equal to, well, approximately 35.9%. So therefore, option A is the correct answer for this question. Now, the next question. What will be the correct number of total electrons in 1.6 grams of methane? So let's start off. Methane, the formula is CH4. Carbon weighs 12 grams. 1 mole of carbon weighs 12 grams. 1 mole of hydrogen weighs 1 gram. We have 4 hydrogen atoms, so that'll be 4 moles of hydrogen. So basically, we now have 16 grams of methane present. So the molar mass of methane is 16 grams. The given mass is 1.6 grams. So therefore, the number of moles of CH4 is equal to 0.1. We need to find the total number of electrons in this particular question. So let's look at the number of molecules. The number of molecules of methane will be 0.1 mole times the number of molecules in each mole, which is 6.02 into 10 raised to 23. So 0.1 is basically 10 raised to minus 1, so therefore the number of molecules will be 6.02 into 10 raised to 22 molecules. Now we need to find out the number of electrons in each molecule. Number of electrons in one molecule of CH4. So carbon has 6 electrons plus 4 times hydrogen has 1 electron. So we have a total of 10 electrons totally. So that means we have 10 electrons for every molecule of CH4. So the number of electrons in 1.6 grams of methane will now be equal to 10 times 6.02 into 10 raised to 22, which was the number of molecules. So therefore, the final answer, the total number of electrons in 0.1 moles of CH4, will be 6.02 into 10 raised to 23. So therefore, among the following options, it is clear that option B is the correct answer. We have 0.1 moles and then 10 electrons for each molecule. So therefore, when we do the total math, we get 6.02 into 10 raised to 23 electrons in 1.6 grams of methane. Let's look at some questions of biology. Urinary bladder is absent in all birds except duck, gull, owl, ostrich. Now, birds excrete uric acid instead of urine. So uric acid is excreted as a paste. So therefore, there is little storage required, and the primary function of the urinary bladder is to store waste materials. So therefore, for most of the birds, urinary bladder is absent. However, there are some birds which do have the urinary bladder, and the exceptions are usually the largest of birds. So therefore, among the following, the ostrich is the largest bird ever. So therefore, option D, ostrich, happens to be the right answer. Other birds with urinary bladder include the emus and the rheas, etc. So the big birds like the ostrich, emu, and the rhea, they all contain the urinary bladder, but of sorts. But other birds, since they excrete uric acid, they do not need a urinary bladder. So it's absent for other birds. Option D, ostrich, is the correct answer. C, B, and A, ducks, gulls, owls, they all excrete uric acid, so therefore they do not need a urinary bladder. Now, the final question of this episode. Who developed DNA fingerprinting? Is it T.H. Morgan, Alec Jeffreys, Frederick Sanger, or Francois Jacob? So option D, Francois Jacob. Francois Jacob is associated with his partner Monod, and both of them worked to develop research regarding transcription of DNA. So both of them are related with how with explaining how the DNA gets transcripted. So how the messenger RNA that's taken out from the DNA gets transcripted to form the proteins and enzymes. So option D is incorrect. Option C, Frederick Sanger. He is a popular name as well, but he is associated with the Human Genome Project, particularly because he developed a form of sequencing of the DNA as well as the protein derived from it. So therefore, option C is incorrect. Option A is T.H. Morgan, and T.H. Morgan is most commonly associated with the chromosomal theory of inheritance. So he was the person who propounded this theory, and he initiated, studies on Drosophila, that's the fruit fly, which was pretty useful for DNA research on chromosomes. So option A is incorrect. The correct answer is option B, Alec Jeffreys. So Alec Jeffreys was the person who used the satellite DNA as probe that showed very high number of polymorphism. So he used VNTR, that's variable number of tandem repeats, in order to fingerprint DNA. So therefore, option B, Alec Jeffreys, is the correct answer. This extract is taken directly from the NCERT, which most schools follow, and from which the question was derived. So that concludes this inaugural episode of UPCET, Questions with Solution. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. For getting the latest updates, please don't forget to press the bell icon that's present below the video. So until the next webisode, take care, stay safe, bye-bye for now.